Ignition sequence starts.
Good morning. Welcome to Mission Control Houston. You're looking at the International Space Station Flight Control Room and the specialists who are monitoring the systems on the station and working with the Expedition 62 crew members as they finish up their work week and look forward to an off-duty weekend. Commander Oleg Skripochka and flight engineers Jessica Meir and Drew Morgan have spent a good bit of time this week unpacking the Dragon cargo ship that arrived Monday morning, filled with crew supplies and materials to support dozens of science experiments, both inside and outside the station.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. A new cargo vehicle has arrived at the station, bringing with it a variety of new science experiments to be conducted on board. After its launch on March 6, U.S. time, the SpaceX CRS-20 Dragon capsule rendezvoused with the orbiting laboratory, bringing with it more than 2 tons of cargo. On Monday, NASA astronauts Jessica Meir and Andrew Morgan used the Canadian robotic arm on the space station to capture the Dragon cargo vehicle and berth it to the Node 2 Nadir port. Stowed away on CRS-20 was many new scientific experiments for the crew to perform, including biological research investigations studying microgravity's impact on stem cells, intestinal diseases, and chemical reactions. Dragon brought the first external commercial research platform to be installed on the station, called Bartolomeo, named for the younger brother of explorer Christopher Columbus. This external payload platform was developed by Germany's Airbus Defence and Space and will be operated by the European Space Agency. Bartolomeo will provide power and data transmission for up to 12 payloads that are mounted outside the orbiting laboratory. Also arriving on Dragon are several new Missile Sample Carriers, or MSCs. Drew Morgan took time this week to install the new MSCs onto the transfer tray that is used to transport the sample carriers through the GEM airlock outside into space. From there, the MSCs are attached robotically to the Missile platform. Missile is an external platform that provides the ability to test materials, coatings, and technologies, or other larger experiments in the harsh environment of space, which is virtually impossible to do collectively on Earth. Testing in low Earth orbit allows researchers to see how technologies react to exposure to the space environment, including ultraviolet and ionizing radiation, charged particles, and micrometeoroids. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
The scientists who developed those experiments spent years getting them ready to fly, and they're now poised to work with the station crew members to carry out the protocols. In the next episode of the new NASA Explorers series, we look in on this step in the process for a previous team of scientists when their experiment reached the International Space Station and the expedition crew members opened the package.
Choose your lettuce leaf.
Cheers.
Cheers. We get balsamic? Oh, that's pretty good.
Wow.
It's a salad. It's a salad. JC, that was delicious.
Let's be all Serena, that sounds great.
Well, when you haven't had a salad in 6 months, it's delicious. I'm still stationed on 2 for Nanorax.
With you on 2 for Nanorax.
Right, how's your view? Do you want anything different?
View looks great.
No, the view looks great, thank you.
Now that the experiment is aboard the space station, it's time for the astronauts to get to work. Elaine and Paris Stu are back in Virginia, and the NanoRacks team is back in Texas, where they will perform a ground control version of the experiment being conducted by the crew in space.
The crew members are using the NanoRacks plate reader to read the plates. They're analyzing what's in the plate and the migration of fluids between the two chambers that are on the plates. And so we have our ground samples here. These are identical to the ones that are on the space station. And what we're going to do is, as the crew members insert the plates into the plate reader on the space station, we're also going to insert the plates onto the ground unit we have behind me. And that's just to confirm that what we're seeing, any effects that we do end up seeing, is effective the space environment compared to the ground unit. In summary, what the plate reader does is, it's called, the big fancy word is a spectrophotometer. And it's got a big lamp in it that shines white light, and then it's got a prism or grating. And the white light shines on the grating, and then it moves to orientate to kind of separate the light into a wavelength. And you get to select which wavelength you want to shine through your samples. We have 6 plates. Each plate takes about 4 minutes, so it's about 30 minutes each. And every time in between, we'll be listening for the crew member to say that they inserted the plate. Then we'll hit the command here. Once the run is done, the crew member will come over and take the plate out, put the new plate in, and it'll repeat for 5 more times.
Space Station on 3, plate 1003 is in the tray.
Oh yeah, it's reading the plate. It's got a little, the plate sits in there, moves the plate this way, and then the read head moves this way. And a little here, that's kind of the lamp that's in there that turns the lamp on. Sounds like bad techno music.
My crewmate actually was the first one to start this experiment, and I took over for him and said, hey, what experiment is this? What are we doing? And he looks at me and he says, I'm not sure. So we called down to the ground, to Mission Control.
And I know that part of this is we're looking at a gel that can release antibiotics, kind of slow release to a wound site. But I don't know what happened to that plate in the NanoRacks reader this morning, and then kind of what's going on this afternoon.
What we're looking for is how the drug migrates through the gel over time, which is why we're scanning the plates 2 times a day for this 2-week run.
I like that answer. That's very cool. Thank you for finding that out.
No problem.
So this is 15 days. It's twice a day, and they're typically in the middle of the night, which is the morning for the crew on space station, and then usually sometime in the late morning, early afternoon here. But Kyle's been running the show. He's been getting up every 6 hours, 8 hours, 7 hours to do this. It's kind of fun in a way. I get to play astronaut on the ground, so that's always fun.
After 15 days of running the experiment, the researchers have a lot of valuable data about how hydrogels behave in microgravity. To learn even more, the samples will come back to Earth for further analysis. For the last leg of their journey, the samples will return to Earth in the same Dragon capsule that gave them a ride to microgravity. After Dragon splashes down in the Pacific Ocean, it's taken to the port of Long Beach, where NASA will be ready to retrieve the precious cargo.
Splashdown for Dragon was on Sunday, I believe. And so NASA has a group called Cold Stowage and Cargo Manifest, and they go out and pick up the payloads from Dragon. And then they distribute it to people at LA or whoever needs them there, and then they bring them also here to Johnson Space Center. And so now I'm out front at the Cold Stow office, and I just picked up Module 74, which is our Tympanogen project. And they hand it to me, and I put it in my cooler, and then I drive it over to our office, where it's going to sit until we fly up to the Tympanogen office in Richmond, Virginia, to do the final phase of the experiment, which is removing the samples out of the reactor microplates. We're really proud to take part in this really interesting experiment.
When we first got our gels back, it was already exciting because space never loses its cool, and so we had these places where, oh my god, these are what the astronauts touched. And so we opened up and they've been to space and back, and now they're in our lab.
A few minutes ago, Kayla told you about hardware for a couple of experiments that are going to use the exterior of the International Space Station as their laboratory bench. Well, there's a big experiment already out there on the starboard truss that was recently put back in service after a series of spacewalks, getting it back to work searching for cosmic particles which originated billions of light years away and which may hold the key to the origin and composition of the universe.
Humans have observed many wonders across the cosmos, yet much of our universe is still shrouded in mystery. Among those mysteries is the formation of our universe, which should have resulted in a balance of matter and its corresponding counterpart, antimatter. Much of that matter is thought to exist in the form of dark matter, which can't be directly observed. Much of the antimatter can't be found at all. Studying fundamental particles originating from sources up to billions of light years away may hold the key to understanding both the composition and history of our universe. Welcome to the world of particle physics, currently being explored from low Earth orbit by the Alpha Magnetic Spectrometer, or AMSO2, installed on the International Space Station, or ISS. Planets, stars, interstellar gas, dust. What we're able to observe across the universe comprises less than 5% of the total content found throughout the universe. The other 95% is dark. Dark matter as well as dark energy. Dark matter doesn't interact with or produce light as far as we know. It doesn't consist of normal matter, or matter that can be observed directly. So how do you improve understanding of something that can't be observed? One way is to look for evidence of its interactions. Kurt Costello, the ISS program chief scientist at Johnson Space Center, explains how the giant magnet of AMSO2 is working to help scientists test and modify their theories. Scientists are using AMSO2 to look at cosmic rays, charged particles that travel near the speed of light. AMSO2 categorizes each cosmic ray, looking at a high energy range to see whether that stellar phenomena that we can measure can account for all of the cosmic rays we're seeing. But if you see something in the spectra that doesn't fit, then this could be evidence of dark matter interactions. By studying cosmic rays, scientists are also able to search for antimatter. The Big Bang theory of the universe's origin requires a 50-50 ratio of matter to antimatter. But to date, the amount of antimatter found doesn't come close to matching the amount of matter known to exist. Costello says one of the goals of the mission is to detect antimatter and see if there are any large collections of it out there somewhere. When particles pass through the strong magnetic field produced by AMSO2, their paths bend. Antimatter particles stand out because their paths bend in the opposite direction compared to matter particles. The instrument searches for antimatter with a sensitivity 3 orders of magnitude greater than the original AMS, which flew in space in June of 1998 aboard the Space Shuttle Discovery. This could support the discovery of antimatter pools that were previously undetectable. A key factor in our ability to get the most out of AMSO2 is time. Originally expected to have a lifespan of 3 years, the instrument has continued to perform into its 8th year of operation aboard the orbiting laboratory. In late 2019 and early 2020, astronauts conducted a series of spacewalks to replace AMSO2's cooling pumps, which were failing. Extending the life of the instrument will provide scientists more time in their quest to unveil some of the universe's greatest mysteries. For more on scientific studies being done on and from the space station, go to www.nasa.gov/ISS-science. For more information about the origins of the universe, visit science.nasa.gov.
During those recent spacewalks to get the Alpha Magnetic Spectrometer back in operation, astronauts Luca Paritano and Drew Morgan made use of a special new tool developed by college students here in Houston in order to complete some of their tasks. Here's a look at how the Artemis generation is contributing to NASA's mission right now.
subscribe for more space.
Along with the hands-on work with science experiments and spacewalks and visiting vehicles, International Space Station crew members use some of their time for educational events in which they talk about science with students on Earth, as you may have just seen Jessica Meir do a few minutes ago. Explaining STEM topics to students is an important part of the station's education mission. In this demonstration video, Randy Bresnik demonstrates Newton's second law of motion.
Hello everyone, I'm astronaut Randy Bresnik, living and working aboard the International Space Station. Now, on the space station, we live in a microgravity environment. Do you think the laws of physics will hold up? Come on, let's go find out.
The acceleration of an object depends on the net force acting on the object and the mass of the object, or F equals ma.
Jolly good show, Sir Isaac.
Here we see that once the force of the thrust is greater than the weight of the vehicle, the rocket begins to accelerate.
All right, we're going to start with something small, something you might have at home, a little stick of chapstick. We'll go ahead and use our force, being our bungee cord here. We'll put it on our bungee, and we'll pull it back. Let it go. And you can see how fast it accelerates because there's very little mass. Next, we'll try a little spaceship. A little more massive, and you can feel that because as you move it, you can feel that the kind of the force, the extra force you have to push with your hand. So we'll put our spaceship on our launcher here, same spot. Notice it's flying a lot slower than that chapstick did. What we've seen is the same amount of force on a smaller, less massive object means the acceleration is faster. Well, this is the biggest and most massive thing we have, so let's see how the acceleration is affected. Pull back the same amount on the force, and here we go. And there you have it, Newton's second law of motion in action. Thanks everybody for exploring a little physics with me today. Now I'm going to send it back to Earth so you can start your experiments. See you again real soon.
"5 weeks from now, after another Soyuz delivers 3 more crew members to the International Space Station, these 3 Expedition 62 crew members will head home. And that'll wrap up Jessica Meir's first spaceflight, but not her first mission in an extreme environment. She studied penguins in Antarctica and mapped caves in Italy, 2 activities that prepared her for the ultimate extreme environment.
The thing that's always driven and excited me is exploration in general. So I think I've always been attracted to these extreme environments, places where fewer people have been, where conditions are a little bit more harsh, a little bit more rare, and really extreme in general. I went to the Antarctic 5 times. 4 times was for my PhD research. And the work that we were pursuing then in the Antarctic was looking at the diving physiology of emperor penguins. They use this really big drill to create a hole in the ice, and so you enter the water through that hole in the ice. The first time you go diving through the sea ice hole, you really never forget the feeling. The water down there is a constant -2 Celsius, so 28 degrees Fahrenheit, and you can see rays of light coming in from any crack or hole anywhere around the area. And that's where you start realizing all of the color and the beauty in the Antarctic is. It's just an extraordinary experience, and the things that I saw underwater there is definitely the most remarkable and exceptional diving I've ever had. One of the things that we use for training for spaceflight for astronauts from all of our partner agencies is training in analogs. So if you try to think, what are useful training platforms on the Earth? How do we replicate all of the characteristics of a space mission? One of the analogs that the European Space Agency developed is called CAVES, and it's a technical caving mission. So the CAVES training mission was in this very extraordinary cave in Sardinia. So you would sometimes be crawling through a hole that when you see it in the distance, you don't think there's no way that you could even fit through that. You know, one at a time, we would take off our packs and sort of shimmy like a snake through these tiny, tiny little holes. And then all of a sudden you would come out into this room, this cathedral with a 100-meter granite wall. I mean, it was really just extraordinary. And then we would go on daily excursions, doing scientific experiments, exploring, mapping the cave. So all really similar things that we would do when we finally get to the point of exploring another planet, for example, as astronauts. And then also emphasizing all the other skills that we use on the International Space Station. The other connection that's really important to me is that all of these environments involve natural phenomenon on our planet. So it all goes back to my interest in biology, looking at this remarkable diversity in the animal kingdom with my previous research, exploring all of these amazing landscapes and ecosystems on our planet, and then eventually when I have the most extraordinary of any view, when I'll be on the space station in a couple months, looking down and seeing this magnificent planet Earth and seeing the beauty of our planet and really understanding how special it is and how fragile it is and how important it is to protect it, to take good care of our home planet, to protect our oceans, to protect the land, and to be really a good steward in our universe. I'm Jessica Meir. I'm a scientist and a NASA astronaut.
There's a good chance that once Jessica Meir returns to Earth next month, she'll be able to confirm her pre-flight belief of what she might feel about the planet Earth when looking down on it from orbit. Her astronaut classmate Nick Hague, who was only a few months ahead of Meir in getting to the space station, is one of many who report a change in their perspective on a lot of things after getting a wide-angle look at the whole planet from 250 miles up.
I think the first time I really got to soak in the view was in the cupola on the station, and to just sit there and think. You know, the colors jump at you, the perspective jumps at you and challenges you in multiple ways. I think it evokes, you know, all these different sensations. The largest emotion that I'd feel out of it is I felt this connection. All of humanity's here on this globe. You realize just how special the place we are is, and you feel that connection. And when you see the impacts that we can have on the land, it gave me this overwhelming sense of stewardship and just wanting to try to, you know, come back and take care of the planet a little bit better than I had before, and help convey the message that, you know, we're on this place together, and, you know, we explore space together, but we also live here on Earth together and need to work together to make sure the Earth stays as pristine as it can be. During my third EVA out there, I can remember we were working on the front of the space station. And so I finished up that task, and then to catch my breath, I just kind of propped myself up on the front of the station looking forward, and it's just the Earth arced out in front of us, slowly gliding by, and I felt like, you know, I was just riding the station through space. You know, it's stuff you think about, you know, you see in the movies, but it's this overwhelming experience of, I can't believe I'm here doing this, and that's going below me, you know, that I get to see this. So I can distinctly remember waking up one morning, couldn't sleep for whatever reason. It's like 4 in the morning. I was like, hey, we're in a night pass. I'm gonna go down to the cupola. I'm gonna drink my coffee and just stare at the stars. And there's just so many. And the longer you stare, the more you see. You start with just the big bright ones until your eyes start to adjust to the dark, and then they open up a little more. And when your eyes open up a little more, you see all these smaller little stars. And then once they open up enough, then you can start to see all of this cloudy structure, and you realize that the depth of what's out there, I can only see the tip of the iceberg. So it definitely puts you in your place in terms of, how big am I? How big are we collectively as humanity sitting here on Earth? Being able to look at the Earth from that vantage point and simultaneously see myself as part of something so small in the great cosmos, but also part of something so large as the Earth that's below me, made me realize at a deeper level that I may be one small individual that's part of humanity here on the ground, but I can still have an impact, and I can have a large impact but still be something very small. That balance of perspective has given me a sense of empowerment that I hope that everybody could share in terms of you can make a difference. The Earth is an amazing place. It is unique. When you look out into the depths of space, you realize just the vast ocean of darkness, and we're on this little island, and we're on it together. And we need to figure out how to work together for the benefit of everybody.
If you'd like to get another look at any of the stories we showed you today, and you probably do, check us out on YouTube and Facebook at either of both of these addresses. When you get there, look around. You will find lots of other things, very interesting stuff about NASA and America's human spaceflight program. And if you're going to be out there on the internet anyway, check out Houston. We have a podcast. Every Friday, we talk with people about their work in all aspects of space exploration. In today's new episode, Gary Jordan talks with Chris Romig, the Commercialization Services Lead in NASA's Technology Transfer Office. They discuss how stuff developed for the space program is being made available out in the world at large. Go to nasa.gov/podcasts for today's episode. It's where you'll also find all of the previous episodes. You'll also find all of the other NASA podcasts there, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.